Hi, my name is Katya Flaska,
And I'm Jared Olson.
Mary King.
RJ Phillips.
and our group for our manufacturing analysis project did a blender bottle.
So this is our product. It's a blender bottle. It's typically used to mix up protein after a really hard workout. But for our product, there are 5 main parts. There is the lid, the flip cap, the carry loop, the bottle body, and then the whisk ball. And then our assemblies, the first sub-assembly is just the lid with the flip cap and the carry loop. And then the other sub-assembly would be the lid on the bottle body.
So this first drawing is our SolidWorks assembly drawing of our first sub-assembly of the lid, which just includes the lid and the flip cap. This is our redesign drawing where we removed the carry loop. And then the second drawing is the full assembly of the bottle body with the lid and just the flip cap on top of the lid.
So next we're moving on to the original manufacturing processes of the bottle. The main body, lid, cap, and carry loop are made by injection blow molding the high-density polyethylene to get the desired shape, which is then heat treated to increase the strength and durability of the plastic. The injection blow molding machine is based on an extruder barrel and screw assembly which melts the polymer. The first stage of the process is when the melted plastic is injected into a split steel mold cavity from the screw extruder. The mold produces a preform which is then transferred on a core rod to another cold blow mold cavity. Then air is injected through the core rod into the preform, which inflates it to the final shape. After cooling, the blow mold will open and the core rod is rotated for ejection of the product. The whisk ball is made by cold working wire on a CNC machine and then electropolishing to improve surface finish. So the only change we made to the bottle was to remove the carry loop. It doesn't provide much value to the final product, and removing it will significantly reduce the manufacturing time and the cost of the final product. We also decided to manufacture the rest of the bottle assembly with rotomolding instead of injection blow molding.
So this is our DFA analysis for our redesigned blender bottle. We only removed one part from the blender bottle, but overall it really improved the manufacturing of the product. So by reducing one part, we increased our theoretical efficiency to 75% and our practical efficiency to 100%. And our error proofing factor went down to 0.33. Our handling factor went down to 0.33. Our insertion factor went down to 0.67, and our secondary operations factor went down to 0.33. So this is the comparison of our DFA analyses from our original part to our redesigned part. As you can see, by reducing the whole product by one part, it increased our theoretical efficiency by 15% and our practical efficiency by 20%. It cut our error proofing in half. Our handling factor remained about the same. Our insertion factor went down by about half, and our secondary operations factor was also decreased by about half.
The new manufacturing processes that we have chosen to change for our part is a move towards rotor molding in place of injection molding. This will lead to a drastic reduction in costs and a mild increase in the time of production. Another benefit of rotor molding is the amount of money saved due to a higher percentage of material being used and not wasted, making it also more environmentally friendly. For the case of the whisk ball, there is no real viable alternative to cold working, so we will leave that process unchanged.
So this is our final functional prototype, which is a 3D printed lid and flip cap. We decided to only 3D print the lid because that's where the final design changes were, with removing the carry loop. And that's our final presentation. Thank you.